Hey guys, this is item number 2 in problem set 3. So it's asking to find the distance between the inscribed circle, which is going to be inside of the triangle, and the circumscribed circle, which is the circle that connects all three vertices of the triangle as well. So first I started by recreating the 5, 12, 13 triangle here, as you see. Then I knew that the inscribed circle is found by finding the angle bisectors of each angle here. So we find the angle bisector, and the intersection of all the angle bisectors is the center of the inscribed circle. That point, the intersection here, is called the incenter. Okay, so we'll find all these. And we got our point there that we can plot. Clean it up for me. Now we create a circle with the center at D here, and then we make it tangent. So all the sides of the triangle are going to be tangent with that circle. So a point is going to be lying on one of the sides there. That'll create that inscribed circle. And then for the circumscribed circle, what I did was I knew that the circumscribed circle here was connecting all three vertices, but I also knew that the circumscribed circle has a center at the point called the circumcenter, which is found by the intersection of all the perpendicular bisectors of each side of the triangle. So we find each perpendicular bisector here. We can plot a point right there in the intersection of them all. Perfect. See, perfect. So then we got that center point F, right, and we'll create that circle. So we take our center point F, drag it out to one of the vertices, and that gives us our circumscribed circle there. Now the question's asking, what is the distance from the center of the inscribed circle to the center of that circumscribed circle on the same triangle? So we just come up here and find a distance from D to F. And we get 4.03 to be the distance from the inscribed circle, to the center of the inscribed circle to the center of the circumscribed circle.